Section 1. Introduction. Data is the lifeblood of modern businesses. Protecting this data is critical to success. Data loss can lead to financial damage, legal trouble, and reputational harm. Oracle Database provides robust mechanisms for data protection. Backup and recovery are essential aspects of Oracle Database administration. They safeguard data against unexpected events. Effective backup and recovery procedures minimize downtime and data loss. A well-defined backup and recovery strategy is crucial. This strategy must be tailored to specific business needs. Factors to consider include data criticality, recovery time objectives, or RTO, and recovery point objectives, or RPO. The strategy should outline backup frequency, types of backups, storage locations, and recovery procedures. Regular testing and updating of the strategy are vital to its effectiveness. Backup and recovery operations are not a one-time task. They require ongoing attention and maintenance. Database administrators must stay informed about new features and best practices. Oracle Database provides a range of tools and technologies to support backup and recovery. Understanding these tools and how to use them effectively is essential. By implementing a comprehensive backup and recovery plan, businesses can protect their valuable data assets and ensure business continuity in the face of adversity. A proactive approach to data protection fosters confidence and resilience, allowing businesses to focus on their core operations without the constant worry of data loss. Investing in a robust backup and recovery strategy is an investment in the long-term health and success of any organization that relies on data. Section 2. Backup types. Oracle Database supports various backup types. Each type serves a specific purpose and offers different levels of protection. Understanding these types is crucial for choosing the most suitable approach for your needs. Logical backups capture data structures and content using SQL statements. They are useful for moving data between databases or creating portable copies. Physical backups work at the file system level, copying data files directly. They offer faster backup and recovery but are platform dependent. Full backups copy the entire database, providing a complete snapshot at a specific point in time. Differential incremental backups capture only the changes made since the last full backup. Cumulative incremental backups capture changes since the last full or cumulative incremental backup. Incremental backups save time and storage space but require a chain of backups for recovery. Choosing the right backup type depends on factors such as database size, required recovery time, storage capacity, and backup frequency. Full backups offer the simplest recovery but require more time and storage. Incremental backups are faster and more efficient but introduce complexity in recovery. Section 3. Recovery processes. Recovery is the process of restoring data from a backup. Oracle Database provides different recovery processes to address various scenarios. Understanding these processes is essential for effectively responding to data loss. Instance recovery is an automatic process that occurs when the database instance restarts after an unexpected shutdown. It uses redo logs to replay uncommitted transactions and bring the database to a consistent state. Media recovery is a manual process used to recover from physical data file loss or corruption. It involves restoring data files from backups and applying archived redo logs to recover changes made after the backup. Complete recovery restores the entire database to a specific point in time. Incomplete recovery allows restoring to a specific SCN or timestamp, providing flexibility in recovering specific data subsets. Point-in-time recovery, or PTR, leverages archived redo logs to roll back the database to a specific past time, even without a corresponding backup. The choice of recovery process depends on the nature of the failure, the available backups, and the desired recovery point. Instance recovery handles most common failures, while media recovery is necessary for data file loss. PTR offers granular control over the recovery point, allowing for selective data restoration. Section 4. Instance recovery. Instance recovery is an automatic process that ensures database consistency after an unexpected shutdown. It is a crucial part of Oracle's architecture, ensuring data integrity and minimizing downtime. Understanding how instance recovery works is fundamental for any Oracle DBA. When an instance crashes or shuts down abruptly, uncommitted transactions remain in the buffer cache. These transactions need to be rolled back, and committed transactions not yet written to disk must be applied. Redo logs, which record all changes made in the database, play a vital role in this process. During instance recovery, Oracle reads the redo logs and applies the necessary changes to the data files. Uncommitted transactions are rolled back, ensuring data consistency. Committed transactions are written to disk, guaranteeing durability. This process happens automatically without user intervention, ensuring a quick and efficient database restart. Instance recovery is a complex process involving various background processes and memory structures. Understanding its intricacies helps DBAs diagnose issues, optimize performance, and ensure the smooth operation of the database. A well-configured database with adequate redo log space ensures swift and reliable instance recovery, minimizing downtime and data loss. Section 5. Media recovery. Media recovery is a manual process used to recover from the loss or corruption of data files. It is a critical procedure for restoring data when instance recovery alone is insufficient. Understanding media recovery is essential for handling severe database failures. Media recovery involves restoring damaged or lost data files from a backup. After restoring the data files, archived redo logs are applied to reapply all changes made after the backup was taken. This process brings the restored data files up to date, ensuring data consistency. The steps involved in media recovery include identifying the affected data files, restoring them from a backup, and applying archived redo logs. Oracle provides various commands and tools to facilitate this process. The RMAN utility simplifies media recovery, automating many of the steps and providing a user-friendly interface. Mastering media recovery techniques is vital for DBAs. It equips them to handle data file corruption, accidental deletion, or storage media failures. A well-defined media recovery plan, coupled with regular backups and adequate redo log management, ensures a swift and effective response to data loss incidents. Section 6. Failure types. Oracle databases, despite their robustness, are susceptible to various failures. These can range from minor hiccups to catastrophic events. Understanding the different types of failures and their potential impact is crucial for crafting effective backup and recovery strategies. Statement failures are the least impactful, affecting only individual SQL statements. User errors, constraint violations, or data inconsistencies can cause these. Process failures are more serious, involving the termination of a user or background process. These can stem from application bugs, resource contention, or external factors. Instance failures, as discussed earlier, involve the abrupt termination of the entire database instance. These can be triggered by hardware failures, operating system crashes, or power outages. Media failures are the most severe, involving the loss or corruption of storage media containing database files. Disk crashes, controller malfunctions, or physical damage to storage devices can cause these. Recognizing and classifying failure types allows DBAs to implement appropriate preventive measures and recovery procedures. Understanding the potential causes and consequences of each type of failure aids in developing a comprehensive backup and recovery plan tailored to the specific risks and vulnerabilities of the database environment. Section 7. Strategy planning. A well-defined backup and recovery strategy is the cornerstone of data protection. It outlines the procedures, tools, and policies for safeguarding data and ensuring business continuity in the face of failures. Developing a comprehensive strategy requires careful planning and consideration of various factors. The first step is to define recovery objectives. Recovery Time Objective, or RTO, specifies the maximum acceptable downtime after a failure. Recovery Point Objective, or RPO, determines the maximum acceptable data loss. These objectives drive the choice of backup types, frequency, and storage solutions. Next, consider the available backup and recovery tools. Oracle provides various tools, including RMAN, Data Pump, and SQL Loader. Each tool offers specific capabilities and advantages. Choose the tools that best align with your recovery objectives and technical expertise. Finally, establish clear procedures for performing backups, testing recoveries, and documenting the entire strategy. Regularly review and update the strategy to accommodate changes in business requirements, technology, and risk profiles. A well-documented and regularly tested strategy ensures a swift and effective response to data loss incidents. Section 8. Testing and updating. A backup and recovery strategy is only as good as its execution and validation. Regular testing and updating are essential to ensure the strategy's effectiveness and adapt to evolving needs and technological advancements. Testing backups involves restoring data from backups to a separate environment and verifying data integrity. This process validates the backup process, identifies potential issues, and provides valuable experience for handling real-world recoveries. Regularly review and update the backup and recovery strategy to reflect changes in business requirements, data volumes, risk profiles, and technology. New backup and recovery tools, techniques, and best practices emerge constantly. Staying informed and incorporating relevant updates ensures optimal data protection. Testing and updating the backup and recovery strategy should be an ongoing process, not a one-time event. Regular testing builds confidence in the ability to recover data effectively. Continuously updating the strategy ensures it remains relevant and aligned with the ever-changing technological landscape and evolving business needs. Section 9. Conclusion. In the digital age, data is a critical asset for any organization. Protecting this asset from loss or corruption is paramount for business continuity and success. Oracle Database provides robust mechanisms for backup and recovery, empowering DBAs to safeguard valuable data. Understanding the different backup types, recovery processes, and failure types is crucial for crafting an effective backup and recovery strategy. Oracle offers various tools and techniques to facilitate these processes, from automated instance recovery to manual media recovery. Choosing the right tools and techniques depends on the specific needs and risk tolerance of the organization. A well-defined backup and recovery strategy is not a static document. It requires regular testing and updating to ensure its effectiveness and adaptability to evolving business needs and technological advancements. By implementing a comprehensive and dynamic backup and recovery plan, organizations can protect their data assets, minimize downtime, and ensure business resilience in the face of adversity.